All right, so let's talk about binary. Who can walk me through what binary is? Right, so base 2 number system. What's important for you to remember is the conversion between decimal and base 2, like how we can count to those. Right, at this point, you don't need to go super high, but we need to understand how that functions. You can tell me how it functions, how the counting functions in binary.
It goes the order of 0, 1, 0, 1, and so on. Like that, then you do it increase by power of 2 every single time.
Open, closed.
You've got to be kidding. Oh, because. Yeah, so it's going to be, so it's 0, 1, 0, 1, that's true, but let's try to define that a little bit better. If we think about it as 0, 1, 0, 1, right, that's really just 1, 0, 1,
Yeah.
which would be what?
1, 0, 1, 7.
1, 0, 1, 5.
What? Yeah, 1, 0, 1 would be 5. Okay? Now let me walk you through how so that we can see it, because it's important that we're all sort of on the same page. Okay? So, binary. Very quickly, we'll try to go through this as quickly as we can. All right. So, if we look at this, guys, the binary for this, if we think about binary, remember that you're going to figure out bases based on their position. So, if we have, right, a base 8, or I mean, excuse me, not a base 8, an 8-bit binary number, right? If we do that, remember you're going to actually see that a lot. A base or an 8-bit number, right? We see that in RGB. We're going to see that with keyboard strokes and stuff like that. So if we do this, this is the which column? Okay, and we know that we can figure out the columns by multiplying by the base each time, right? 2, 4, 8, 16, 32, 64. You guys doing great. Okay, what's the max value of this column?
127.
Incorrect.
128.
128 is the max value of this column.
128 times 2 minus 1.
It is
Or 255.
exactly 255.
Yeah.
Right. So the next column, if we think about this, the next column here would be 256. So the way that works is if you imagine that all of these are full, right? Then that means that it is going to be one less, right? If we're just thinking about it from a logic standpoint. You're thinking of one less than the next column value, right?
Yes.
Okay. So that's how we're going to add this up. So if I were to give you, the nice thing about binary is that you don't have to deal with multiplication. You literally just add it up, right? Because you can have multiple values in one column. Yeah.
Are we going to have to add binary numbers?
So if I said to you what was, right? Because if I was going to ask you this, if I was to say what is 0, 0, 1, 0, 1, 0, 0, 0, what would that be? You just look at the value of that column and add them up. So that's 40.
Wait. Okay, yeah.
Okay? So this is easier than decimal because you only can have one value in a column. Right? So you either count it or you don't. Yeah.
Are we going to do any coding with binary?
We're going to do a little conversion, but it's really important that you know this so that you understand how the values work, right? Because one of the things that happens is if I do this, if I have this number right here, right? And so this is going to give me 255. And that value is going to be for an RGB, right? And you want to have red, but you accidentally add, like you write a script that adds more than this. So you have 256, right? If you have that value, it would read red as 0. Anybody tell me why? Right, because it's going to think that you have a 1 here, and then 0, 0, 0, 0, 0. But when it reads the color, it's only going to read these. Right? It's going to confuse you, and then all of a sudden it's reading the wrong data, and you're lost. Right? And all of a sudden you're like, why is this color turning out black? It should be red. Okay? So you need to understand this. And really this is at the heart of computers, so it's just a fundamental knowledge base that you need to have. Okay? Questions? All right. So if we go back to the computer, let's see. So we got binary, hexadecimal, base 16, right? Instead of having 1 through 9 or 0 through 9 works, but then we run out of numeric symbols, so we have to switch to alphanumeric A, B, C, D, E, F, G, right? Or F, excuse me, not G. Should say, right? So 0 through F is going to be hexadecimal, right? And that's going to show up. So if we look at the conversion of this chart, right, of the hexadecimal colors, and I put F, 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 what is that going to tell me? What color is this going to be?
White.
White. If you do 16 times 16 is what?
130.
What?
Do the math first before you.
196?
So remember how many? Do you remember how many bits of information is used for each of these? 8 bits, right? Which gives us 256, a max of 255, rather, right? 255 values. If that's the case for this, what do you think 16 times 16 is going to equal? If we're doing that, right, we have the 1's column, the 16 column, right? And then you have, so this is times 16, right? 1 times 16, 16, 16 times 16. So if we max this out, it is 1 less than this. So this is 255. So we wind
How
up.
many hexadecimal?
So having 2 digits of a hexadecimal number is the same as having 8 bits in binary. Yeah.
How did you know it was white?
How did I know what?
It was white.
Because if you, in generated color, if you jack all the colors up, you get white. Turn all the colors off, you get black.
So we don't have to know the color? Or...
No. I mean, it would be pretty easy to know at least 3 colors, right? So if there was 00FF00, what color is it? Cool. The first 2 represent R. The second 2 represent G. The last one represents blue, right? So green, blue. If you jack it all the way up, right, if you have the maximum value, it means that that color is as bright as it can be. And in this case, it's FF, right, which is the maximum value, because F, remember, is 0 through F, right? So then green, if this was 0, 0, and 0, 0, that's going to be RGB. So F would, or green would be jacked all the way up. So there would be no red, no blue, only green. What color do you think you'd get? Yeah. Okay. All right. Questions about those? All right. Let's scroll down. Object-oriented programming. Talk to me about it.
It's like a specific task that something's made to do.
There's specialized parts.
Say that again.
Specialized parts like working together.
Right. So the objects are things that are discrete, right? They exist as an entity by themselves, and easily definable. Okay. So an object is going to be discrete. It's going to have its own boundaries and be defined. Does it have to be? So this is like an idea, right? It doesn't have to be in physical things. So we can have the idea of a bike without actually having a bike. Correct? Okay? All right? So we have object. So object-oriented programming is about having a series of objects that do different things that interact with one another. Okay? So let's use a school example of this. Let's use like eSchool, right? Or what y'all think of as home access, right? So we would have a course, like this course, right? You would have a student, and then you would have a teacher, right? And these items, these classes, will interact with one another in order to accomplish some task, right? Now, why do we do this?
To make it easier, like,
And if you find something wrong in the code, like an error, it's easier to like identify.
Yeah, good, right? So you know where it is, right? So we're going to maximize efficiency and minimize what?
Error.
Yeah, so we'll minimize complexity. Now, Denise, I heard you say error, right? But that's part of this, right? It actually is. So the complexity, you're going to have errors, but this helps us eliminate where those happen. And if an error happens, it only happens in one place, right? So if you think about this from a procedural programming sort of perspective, so procedural, right, would be I would have a teacher log in. And then I would have that teacher experience mapped out from beginning to end, right? And then maybe I have a student log in or a student page, and their experience is sort of mapped the entire way. Okay? If this happens, if we do this, and then all of a sudden I say, well, you know what? We also want to have clubs, right? If I want to all of a sudden introduce clubs as a new object, right? Same thing here. A student can interact with this. A teacher can interact with it. Maybe in some ways even a class can. Okay? If I do this, I've got to rewrite everything. Right? So procedural is always about, sort of streamline of a process. But it's difficult, right? It doesn't always work. Okay? Yeah?
Would you say that the student is the instance of the school?
Do what? Okay, so think about it. That's a great question because this is where we're getting to the context of this. In the real world, is the student an instance of a school? Talk to me about it. Do I have a door? Do you have a door? Does the school have a door? So this building might be an instance of the concept of school, right?
Yeah.
And a school has students, it has faculty members, it has administrators, right? It has custodians. It has all of that stuff, right? Bathrooms, whatever. But that's not so a student doesn't come from a school. They interact, but they're different objects. Okay? So they can interact together. You would be an example of a student. You would be an instance of a student. Do you know what I mean? So I have an idea of what a student should be. But you're the personification, right? So the idea of a student is going to have a name, is going to have a grade, is going to have a GPA, a schedule, all of those things, right? But all of you are instances of students, but only you have your schedule. You don't come to school one day because you want to see the eclipse. That doesn't mean that everybody else has an absence that day, right? So you are distinct. Everybody has attendance records. But yours is distinct from comms. Okay? That make sense? Yeah.
So what would a student be relative to a school? Would it be an object of it?
So a school, right, would, and we're like, I don't want to get too deep into this because I want to go over the terms, right? But a school would be another object or another class. And one of its qualities is to have a list of students, right? Students that belong to it, right? Let's go back to the bike example. A bike, right? If we think about a bike, we all can sort of define what a bike looks like, right?
Yeah.
But if we actually think about the way that this works, is the bike just a bike? No. It has wheels. That's an object, right? It has pedals. Those are objects. A seat. It has steering, right?
So the whole bike is an object of the program?
Could be. It could be, right? So remember that this is a framework. There's no like hard and fast rules about what is an object and what isn't. If we were working on a project together, the first thing we would do is sit down and go, okay, let's talk about the objects we need. Let's talk about the different classes and how they're going to interact, right? So is a schedule a thing by itself, or is it a is it a relationship for a student, right? A relationship between classes and a student, right? Or courses and a student. Or is it its own, does the schedule exist as its own object, right? And then we'd have that discussion. I go, well, I don't really think it should be its own object because it doesn't really do anything. It's just a listing of information that shows a relationship, right? But a student and a course, those things have qualities, right? Do you know what I mean? Yeah. Okay. So, this is all about figuring out how you think it should work as the programmer. That's one of the hard things about understanding this from the beginning, is that y'all haven't done this. So you're expecting these rules, but really this is a philosophy of thought. How should we go about making this, right? That's the conversation we're going to have. What are the discrete objects that we need to know about as we go forward, right? Okay, so let's see. What else do we need to know? Objects. So we talked about that a little bit. You'll feel comfortable. This is self-referential. That's the only thing I want you to know, right? So if I say this dot schedule, right? And this is for in the student class. This is in student dot JA. It's not a J. JAVA. If I say student.java in here, whose schedule is this? That student. They're referring to their own schedule, not someone else's. Not a little variable that somebody's using for just a minute. It is like an instance variable. It belongs to that class. Okay? All right, that's all you need to know about this for now. All right. And later on, we'll talk about it in more detail. Okay, so what else do we have? Classes. We were just talking about those different classes. Do you feel decent about that?
Yes.
What classes are?
Yay.
We good?
Yeah.
Guys feel okay? What?
Yeah.
No questions. All right. I mean, this is the heart of it, so I want to know if you need it, right?
So, like, world class is just like the general grouping of everything. Is that thought of it?
When you say a general grouping of everything, that makes me nervous.
Well, not general, like grouping of objects with like similar purposes.
No, I wouldn't define it that way. What I would say is when you're thinking about a class, okay? We good, guys?
Yeah.
Kyler. Why do I feel like you and I are going to go round and round? Huh? Do you think it's like this is the fourth time I had to call you out for laugh and carry on in the middle of a lecture? Do you feel like that might lead me to that conclusion? Let me ask you another question. How many times do you think I'm going to talk to you about going off on you before I actually do? Not much more. All right. So if we think about a class, remember, we can kind of think about this two ways, right? So one is it's the idea of a thing, right? Okay, so if I have student, right, as the class, so if I have a new student, public class student, this is not a student, right? It's what a student means, right? What it means when we're thinking about it in terms of abstraction. You know what I mean by abstraction? So abstraction is the idea that you're not. When we talk about a student, I'm not trying to do like some esoteric definition of everything that it is to be a student, right? If I'm dealing with a grading program, I need to know what courses you're in. I need to know what name you have, an ID number for you probably, right? Your grades, and I don't know, parents or something, right? But I don't need everything. I don't need to know like your sign, you know, if you like long walks on the beach or what, like none of that matters, right? All of that stuff is sort of in the real world of student. But for me, I'm abstracting a student down to what I need for a program to run. Okay? That's why, like, when you have a player, you know, like you don't have to give your social security number when you're playing a video game. They want to know, like, your name and, you know, like what your rank is, okay, and what your score is. And that's it. Nothing more than that. So in this context, what do I need? Maybe I need a name, an ID, grade level, GPA, maybe a picture, okay? All that stuff could be what you need, right? And what this does is it tells you how to build, or like how you build a student and how a student acts.
So it's like defining a.
Yeah, so you're going to hear me refer to it interchangeably oftentimes as the idea or the blueprint. Okay? So in other words, like I need to know not just what a student sort of is, what I think about it, but I need to know how to build it. Okay? Now, somewhere else, maybe in the school class, when I'm starting this off, I'm going to say, I want a new student. Okay? And once I say this, it's going to go to the blueprint and build me one.
Okay.
Right? And then put it in memory. Right? So we'll literally go into the disk and it's going to say, here's your address for this place, right? And this is 73256, right? And then now that student exists in the computer program at that spot in memory.
Okay. So
And now I can refer to it separate from any other student.
So now with this, it's not like it's just defining how not an object, but like I guess an object
Yeah.
is created.
And what it can do.
Okay.
Right? So all of the methods that you build are when you're saying this is what a student can do, right? A student can get a grade, a student can give you their GPA, right? A student can submit an assignment, whatever, right? Show up the computer. Right? Okay. So, does this make sense? All right. We good? Okay. All right. So now let's look at what else do we have? So an instance. So I'm sort of talking about that now. If we go back to here, right? This creates an instance. Okay? So when I say new student, hey guys, I know we've been talking about this for several days in a row, but it's a big thing, big quiz. Make sure you stay focused. So this is going to create an instance of the student class. Okay? And that instance, when we talk about that, that means like if we're thinking about students in real life, an instance of it, we've got an idea of what a student is, but you are an actual student. All of you are instances of the classification of a student. Right? Think about it. You always got to remember that way. It's a classification. It's a way to define the group of things. Okay? All right. All right. So now we're talking about methods, and we're going to talk a little bit about methods and about constructors, right? Can y'all tell me the difference between those?
The constructors, the methods are the things inside constructors to combat, while the constructors are to like basically provide the foundation for the objects.
Okay, let me sort of expand on that, right? So we're going to talk about methods first, all right? Because methods are going to have some significant things, right? When you have a method, you're going to have a signature. Okay, that means how does the computer know which method to call, right? So if I have a method signature, it is going to be so let's write a method. So your private. Let's see, int get. Right. So I want you to get the grade level for the student, right? So the method signature is going to be the return type, the method name, and the parameters. Okay? That is going to give you what you need for a method. So this is the signature of a method. Okay? Now, I can change that, right? I can come back and do that a little different. So if this is my method here, I can also go private int get grade int ID, right? So maybe I need to get this from, with a specific ID or like for a specific course, right? Or something. If I do this, the method signature has changed, right? So it's int. Are these the same fingerprints?
No.
No, they're not, because the variables have changed, right? The parameters that you're passing in, or that it needs, right? So these are two different methods. The computer would see two different methods, okay? So if I said over here in another class, student dot get grade 5, which one is that going to call? Which method is that going to call?
The second one, right? There's parameters in the. Since there's something in the.
This would be a variable name that holds an instance of a student. But yeah, I see what you mean. Yeah, but it would throw an error if it didn't see that. Oh, right. Oh, actually, yeah. Oh, right. Did you catch my mistake?
No.
So she said it won't give you anything
If you just did clear.
because it's not public. It's in a different class, so these need to be public.
Is it possible, like, if this is a method inside a constructor, you just type?
You can't have a method inside of it.
No, like, just to clear it without, like, you don't need to clear private public. It's only int get grade and then insert, like, what value it is. Can you still call it, or is that does fall under the section of public?
I don't know.
Basically, like, can you not type public or private or address? You have to declare it.
If you don't, it defaults to public.
Oh.
Which is bad for you because then that means that you would lose points on the exam.
Oh, yeah, that's really good.
Right?
Code you need to be really specific.
Because in the field you want it to function as easily as you can. It's bad form to have everything public. Okay? Alright. Questions about this? Methods, you got the signatures?
Which one? The second one, right?
Yeah. This would call the second one because what is it it's expecting?
There's a value in there.
Yeah, right?
So what would an example for the first one?
It would be so S2 dot get grade with nothing.
And then there would be
Right.
code underneath the first one to say what would happen then.
Yeah, there would be code in here.
Okay.
Right? And code in here. So maybe, so in this one, right, you're just gonna get that the general grade. Here you're gonna get a specific course, right? Okay? Does that follow? Okay. A couple other things about methods that I want to make sure that we touch on. So let's. I don't want to do. Okay. Here, we'll just do it down here. So if we do this, right, and we're thinking about the methods, there's two other big pieces that we need, right? We've already sort of addressed. What are parameters? What are parameters?
Like how you pass values.
Yeah.
Specify how objects are to move.
Okay. So you're going to pass values here, right? So this is where you give information. So these are given to a method. Okay? So parameters are given to a method. They're going to be in the parentheses. So here, right, I have a parameter that I'm passing in, which is int I, right? Or int ID. I'm passing that in. So that goes to the method, right? So wherever you're calling it, you need to have that, right? And it's going to be passed in. You pass the value in. The return type, what's the return type?
It is
Not the return type. What is a return, rather?
It returns the value that you back to you, the end result.
Right? Value given back. Okay? Let me show you an example of that real quickly. So if we have a method, and that method is over here in a class, right? It is, I'm writing in red. It's get random number. Okay? And I just want to get some random value. Right? Sorry, this is gonna, so then in here I say, you know, code to gets random number, right? And then at the bottom of this, I'm gonna say return, and then I need to pick, like I need to say what it is that I'm returning. And in this case, it's gonna be this random number. So let's say that it's R is what I get, right? So gets random number, sets to R. Right, so you would have like R equals random, okay? So then I'm going to return R.
Oh,
Okay.
You actually like write out return.
Yeah, literally I would say return R, or whatever value I'm giving back, right? Over here, if I called that, right, I would say get R, right? And then put this, you know, put the parentheses like this, right? And then that's going to call it. And that value is given, right? So I'm saying give it here and then return it. Now, to give you a better example of this, because that can be a little confusing, let's simplify this a little bit. So instead of saying just get R, I'm going to say x equals 5 plus R, or get R, right? So the way that Java works is it's going to execute this code before it returns the value of x. So what's going to happen here is I say 5 plus get R, right? It sends that over here. It gets a random number, and then it gives it back. What's the random number that it picks?
3, 7.
3 and 7, 10. Right? See how I did that? So it's going to return this, and the value that it's sending back is 10. That gets plopped in where the method is called. So it returns 10, which is now the value that's taking its place. And I have x is now equal to what? 5 plus 10, so x is equal to 15. Okay? Does that make sense, that process, that round trip process?
Yeah.
Okay. Now, let's say that this, I might, you know, it could be like 2 quadrillion, right? If I ask for a number like this, right? All right. So what do I need to add in there? If I want to limit it, let's say I want a max number.
between 1 and 10.
So, well, let's say that I want the user to be able to decide between 1 and whatever, right? Then I'm going to come up here and I'm going to add that in, right? I'm going to go int max, right? So now I'm asking, or I'm telling the code in here. I'm not going to write the code, but the code in here would use that variable, that parameter that's passed in, to say you can't use more than this number. Don't give me a number bigger than this number, okay? That's passed in. So then over here, I would say 10, right? So don't give me a number bigger than 10. This is then passed over. It gives them the 5, or, oh, sorry. It gives them the 10, which is the max value being passed back, right? And then this comes back. You'll see the round trip? Can somebody articulate it for me?
So whatever number you put in after you get R, it won't go any higher than that.
Yeah, right? That's what I'm using this one for. But that don't worry about the actual code. I want you to be aware of the round trip, how the information is exchanged.
When you say x equals 5 plus get R, it goes to the other code.
So it literally goes, okay, I'm going to set the value to X to whatever happens here. 5 plus, and it goes, oh wait, I've got to run this code before I can finish this. So it holds on to this equation, processes this, gets the number. Now it goes, oh, I've got a number to put in place of the method call. 5 plus whatever the random number is that's returned. We get 15. We get the answer, right? And then we move on. Okay? Yeah.
So could you call the R in a later line? Like say 5 plus get R, and then later say like print R?
Over here?
Yeah.
No.
Okay.
Right? And we'll talk about that later, but that's because of scope. Right? So if I declare something in here, it's only going to be visible between the curly braces where it's defined.
So you'd have to say like print get R?
Yeah, I'd have to do that again. Now I could go y equals get R10, right? And then here, do y, right? And I could use y down here, right? Somewhere else, and then y is going to be whatever that value was, because I filled that bucket with the value there.
So
Okay.
the return type is get. No, the return type is R.
Yeah, so we're going to actually write this. The return type is not R. It's returning, that's the variable that it's going to return. It's taking whatever is in the R bucket, right, which is whatever the random number is right now, right, and it's returning it. But when we look at it, right, we're going to say public, right? Now, what kind of a value am I returning? What kind of data am I returning? An int, right? So it's returning an int, get R, right? And thanks. Right? This is what it would actually look like.
Oh, and then like inside that you define. Like you did.
Yeah, then code to get random. Right? I don't want to go, I mean, there's actually code, you'll use random numbers a lot, so I'll show you how to get random numbers. But this is just concept, right? So that we'll wait on. Okay, but that's what I want you to see. So this is encapsulation, right? This is return type. So what am I doing with the return type, Cole? So the return type is saying what kind of value I'm going to return, right? So I'm letting it know, like when you run, you're going to give this back, this kind of value back. And then we have the name and the parameters. Is there anything special about the name? Do what? No, you're thinking of constructor. In this case, it's just descriptive. Have a descriptive name. And then int max is going to be our parameters, right? The values that we need, the information that we need for the code to run. Okay? That is your method.
Is there a particular reason why CompSci teaches us foobar as an int thing?
We're not going to talk about foobar, right?
Because every single CompSci teacher loves foobar.
So that actually stands for something that we're not going to use in class.
Okay.
If you don't know what that is, don't look it up. All right.
Why?
Okay.
Because I'm getting too far into my head again.
It is, the FU in it is a very common expression, right? Okay. All right. So, what else we got? We got that. We got method signature, return type, encapsulation. Talk to me. So the constructor. I don't feel like I need to write a constructor, but if y'all want me to, I will. Don't like phones out. Yeah.
I have a question about encapsulation.
Okay.
How exactly do you see that on the anatomy of it? Is that what the curly braces are, or what exactly is it?
Great question. Okay, so let's look at encapsulation real quick. No. Okay, so encapsulation is just like a visibility level, like where it can be seen. Okay?
So is that the private and public thing?
Yeah,
Okay.
that's absolutely what it is. So if I say private on a method, right, what I'm saying is, here's the class, right, and I have a get GPA, or actually let's not do it get, because gets are usually public. Let's do calculate GPA, okay? And I make that private. Remember, minus sign in code is shorthand for private. So if I make this private, okay, that means that nobody can see it from the outside.
Okay.
You can see it inside of this, right? It's like, do you want this to be a room with a window or a door? Or a window or a wall?
Okay.
Right? So I don't want, like, calculating GPA, I don't want anybody to be able to mess with.
Okay.
Right?
Mm-hmm.
And it works for GPA too. Do you guys want your GPA, like, as a variable? Would you want someone else? Is anybody in the running for a class, like at the top of the class or anything? Pretty cool. If you're running for, like, if you're there and you're running for that, you've got to be, like, you don't want anybody else messing with your GPA, right? I don't want somebody else, like a counseling object or whatever, to be able to change my GPA. I want that to be strictly controlled. So that means that if somebody goes in and they try to get to that, right, they're blocked. They can't see it. Okay? If it's public and it's get GPA, right? Because I do want the counselors to be able to see my GPA so they can tell me, like which school I can go to, right? That needs to be public, and that means that is visible, that a counselor can call that, right? So a counselor can say, student dot get GPA. Now, doing this means that they can see your GPA, but they can't mess with it. This variable is still private, so I can't change it. I can only look at it. Right? Does that make sense?
Yeah, that makes sense. And then on our document thing,
Mhm.
under encapsulation, it says wrapping code and data together. What does that mean?
Delete that line. It's sort of accurate, but you don't want to think about it that way. Basically, it really means to put a capsule around it, right? Like encapsulate it.
Okay.
So if you make it private, it has a capsule around it. It can't be seen outside of that capsule.
Okay, that makes sense.
Okay?
Can you like private and public, but can you make it to specific private for everybody else except for a few?
There are some other ones that we're going to work on later, like protected and final. Like there's some other stuff that we can do. But we're not. Now's not the time for that. Let's just stick with those two before we muddy the waters. Okay? All right. Other questions about this? Variables. Let's talk about variables. That's going to be about it, unless y'all have questions. If y'all want, I'll be here for about 30 minutes after school. So if y'all want to come in after school, you certainly may. Okay? All right. So let's look at variables. What kind of variables have I asked you to know?
Primitive, referenced,
Okay, so primitive and reference. Can anybody give me the definition of this?
Primitives are usually the most basic data types, including the Boolean, which is usually used to mean true or false. The int, which is basically integer number, must be integer double, and then double one is a decimal number. It can also be.
Wait, I just want to talk about these two to begin with, right? So primitive is the most basic data types, correct? Right, good. That's exactly right. Okay, and the reason for that is primitive data types, the basic data types, are small enough where we can hold it, right? We can hold the actual value in the bucket, right? Or in active memory. So I want you to imagine, right, if you think about every character taking up, 8 bits of data, right? And then you have Moby Dick. That's a lot of bits of data, right? So processing that would be really hard. It would take up a lot of your active memory. So what we do is, if it's small enough, like an int, right, or a double, right, or a bit. We're not going to go over all of the data types, so don't worry about that, right? But so these are all small, right? These literally are all represented by ones and zeros, right? Small, like a small collection of ones and zeros, right? Those all can fit in the bucket themselves. They're small enough to fit in the bucket themselves, right? For a referenced variable, you have a hard drive somewhere else on your computer, right? Okay? that holds a lot more data. Okay? And so what reference variables do is they don't hold the actual information. The actual information is held somewhere on the disk, right? Like a class or an instance of a class. So let's say that we have, Moby Dick stored somewhere on here, right? It's a string. It's one group of characters, okay? If this is a string and we have it stored somewhere, then we need to know. Let's say that this is at location 01573, right? Some location on memory. So what is stored in a reference data is not the data itself, but a reference to where the data is stored, right? So do you carry all of your books with you, or do you put some of them in your locker that has an address that you go to get it when you need? Right? So then in here you would have 01573, right? So when you're referring to that data, it goes to the bucket, gets the address, runs out to the hard drive, finds it on the hard drive, and then brings it back. Because now I need it, right? So I'm going to hold on to it. But it only needs it for a split second, and it can clear that data out of active memory. Okay? Does that make sense? All right. Thank you, guys. I'll post this tonight. I'll post it in the classroom.
So is this going to be like mostly multiple choice and some short answer sections and stuff like this? Or will it be just short answer or something like that?
Hang on one second.
Okay.